All right, how we doing, everybody?
Good.
Doing good, happy. Everyone's chilling around, listening, and doing their little things. Meanwhile, I'll talk about. Let me see. Let's see. Wrong page. There we go. Let me see. Lab 3. That's what I've designed over the weekend. It took. Oh gosh, I'll tell you what's going on. If you click on this download button, it'll let you download it. If you click on this, it'll let you view it. Sometimes Adobe pops up, but this time it didn't. This is great. Okay. Anyways, pretty cute assignment. Not too bad. Guys like these little things I put right here. No one's listening or looking at it. It's like, screw this table of contents. Unless you do a thesis. Anyways, let's see. Did everyone look at this assignment? No, not yet. You're about to look at it today, especially now that I have been recording, right? This assignment took me I think 2 weeks to develop, or a week to develop. And I think you guys already saw the hint, or not the hint, but what do you call it? Looked at how tedious this would have been with the resistors and the capacitors and why I was making those funny shapes. But yeah, there are some funny things. I had to read through the manuals, the PDK. Funny enough, it's because someone's saying, David, is the university gatekeeping it? No, we're really not gatekeeping anything unless you let me know. I'll download them for you. Let me go to my. You know what? Let's see if my student account works. Boom. There we go. See if I can access it with my student account. No. And then can I go to what do you call it? CD. Oh wait, CD. Okay, I'm on my root. LSAL. Okay. So it's in CD share. LSAL. Let me see if I can find this for you. CD apps, LSAL, CD Cadence, LSAL. Whoa. Libraries, CD libs, LSAL. Okay, there it is. Okay, we have free PDK 45. This ain't right. Hold up, something's funny. Let me look at something. Okay, whatever. Can I go to my root command? There we go. Let me see if I can find it here. Share. Or let me see. It should be in share. Cadence. Libraries. I'm not liking this. Docs. Let me see what this one is, because it's scaring me right now. Because this, by the way, this is my student account. So downloads, and see if you can download it as a student. Okay, I want you guys having fun with Cadence. Okay, there it is. Oh, okay. Okay. 2011. Great. I'll see if I can do something funny and put the old documents in there. Because let me see. What was it called? Nope, wrong one. Student. There we go. Let me see if I can show you this. Wait, wrong account. Yeah, that's the what do you call it? The different server. There we go. Here it is. No, never save my password, because that means I have to make 2 passwords. Let me go up here. Let me see. Let me go to was it You share apps, Cadence. Wait. Let me see. I remember looking this up. I CDNS. Maybe I'm. Okay, this is this. Where was those folders? Hear me out. I remember I was working on this like at like 2 in the morning, and I was like, I found the libraries and where is it? I'll probably get that to you later. Anyways, I'm not working on that one. Okay. What's the command? Is it called cd $home to get you back to your home directory? Correct. Right. That's your favorite directory. Your home LSAL. Right. Not too bad. cd EE420L lab. Press tab for that. Virtuoso ampersand. Let it do its thing. Yeah, so this assignment was very funny because remember how I talked to you guys about like 2 or 3 weeks ago. I don't remember when we talked about it, but the resistors, the capacitors, there's something going on there, right? Remember? You guys remember that? But point is, what I'm gonna say right now, I'm just gonna get to the end. Chase of this. This assignment can be cheesed in like 30 minutes. I'm telling you that. So please start as soon as you can. Better yet, start now. If you're having cadence errors, such as I had a student who, for some reason, their internet was firewalling something, and I'm like, that's interesting. So if there's unique errors that are not unique to like the machines here, please let me know, because I kind of want to look into them too. And then we had another student, I think maybe Dr. Ming Zhu set their account wrong. And then we had another student who they just declared virtuoso ampersand on their home directory and not in a work directory. So they were getting some weird things. So I think those are like the weird 3 things I've seen. But else, everyone in this room I've talked one-on-one at least can run Cadence, can run the basics. So there should be no excuse for me to extend or this or that, unless like I just say I couldn't give out a lab. So I'm saying this now. I'm trying to make this class is just to teach you Cadence. Have fun. Look through it. Like if you go through this right here. Let me see. Let me just check if I'm recording. Test. Okay. It's my paranoia. Create your low pass filter. I was gonna make you guys do a what do you call a high pass filter, which would have been easy. Just switch the components and then just resim everything. But I was like, honestly, I'm just creating busy work at that moment. So I'm like, because this is the more important part, which was the AC simulations. You're going to be doing AC sims, and you're also going to be doing transients as well. Let me see. And then you guys like this right here. We have 1 volt right here, right? And then what's that number right there? 703, close to 707. Everyone likes 707, or LOL if you turn it around upside down. That's the 3 dB mark, okay? And then I was playing with some things because I had to revisit this too. It's been a while since I've remembered my 420. But what's his name? And I show you how to do the what do you call it? The dBs, the phase, how to save it, because this was really annoying. Just save it. When you save your states, life becomes like sunshine and rainbows. It's nice. How to make sure you change your frequency. Here, what I'm expecting you is look at the 3 dB frequency and tell me if you get that like 45-degree phase shift, and you'll see it. You'll see it when I show you. See, and then you see that right there, that really funny curve. So then remember how I was talking about like funny politics, like, oh, you got to become conservative or conservative accuracy defaults, and then look what happens with this curve. See? And conservative just means we're using the strictest like bounds, and it's using the smallest step size, like even smaller than what your default and it makes it look clean. It takes a more long time. So if you're running like nanosecond, if you have nanosecond simulations, but you're running it for like a microsecond, it'll take like maybe an hour. I'll tell you that. Okay. So if you go liberal, it relaxes it and it just gives you the result fast. Do that for digital design. Digital design fast, okay? But if you're doing hardcore analog, go conservative because we want to have the most precise points, okay? And then moderate is a mix of the two, which I think is the default for Cadence. Then calculator tool, boom, boom, boom. The layouts, and oh god, you know what? And then I even put an example of my previous work. Yeah, you'll probably see that in my website. You see this rail system right here. So that's what I was trying to set you guys up to do some rails, because we're probably going to connect this. Like here's an RC filter, here's an amplifier, and something really simple. Okay, I'll think of an assignment. I still haven't made it yet. I'm just talking about it. And here's your capacitor. Everyone understood what this guy was? What is this? NMOS capacitor. Come on. And then DRC is not too bad. And then I purposely put an error here because I needed you guys to feel my pain too. Was this resistor has 3 terminals, but the way to satisfy it was it took me a while too, which was this, okay? I spent like a whole like 2 days trying to figure out why this resistor was crying, because this would fight because of this, but if I fight with this, then this would start fighting, so these two would just clash, and I was like, what the heck was going on? So luckily enough I was able to catch that, and then that's pretty much it. Okay, not that hard of an assignment. Everyone's gonna get it done, turned in. Yes, or does everyone want to see an example? You know what? Where did I save this? Oh, I saved it in tutorials. My low pass filter. My library. Because I don't want to waste too much time. I'm going to copy this from my tutorials to my library. You know what I'm going to do? I'm going to call it a high pass filter. High pass filter, okay? This is for my future next year's 420. So if they're watching my videos, that's great. If they're not. Anyways, there we go. Yes, press OK. You see, this is what I would have made your experiment 2 been. Just copy paste it, make your high pass filter. What do? Go to my schematic, right? Then how do I fix this? Make it a high pass. Well, if you think about it, it sounds so bad. Don't do... Actually... Tisk, tisk, tisk. I don't think I'm going to want to do that. No, I don't want to make this a high-pass filter at all. Because I'll tell you this, the body, the source, and the drain of the MOSFET, of the NMOS, the body has to be connected to the lowest potential for it to work. You'll see that in the assignment. And you know what? Let's do some headaches. We're going to do some headaches right now, okay? Hopefully this doesn't take too much time. I'm going to move this, buddy. Boom. I'm going to delete this. And actually, what's my capacitance? 15.8. And delete it. I'm going to do something different, okay? Because I wanted to make this assignment a lot more cooler, but I just didn't have enough time. I need to make sure you guys got your assignment to have some ample time to look into it. GPDK. It's going to be called a MIMCAP. There we go. MIMCAPs. MIMCAPs are cute. And let's make it a 3x3. 3x3 MIMCAP. Okay, now this should be good. R2, do that. Highest voltage there. Boom, boom, boom. Okay, because I wanna feel some pain, y'all. Okay, not too much. Okay, I'll stop myself at like 9:45, so I don't go too off track. R. Boom. Okay. And then you know what I'm thinking about this, because I think I think my OCPD is kicking and I don't like it. I'm gonna just do this VSS just for my sanity. How do I get these labels? Oh, let me just check and save. Okay. Cue it. Okay. And then go right here. Press display. Both. Okay. And you know what? I'm gonna put both right here. Both right here. Apply. Okay. See my numbers up here right there. Pretty cool. So that's my capacitor. And the reason why I didn't use a MIM cap, or not MIM cap, a MOSCAP, is MOSCAPs are active components. They're MOSFETs, right? And remember we were seeing that weird, like, for the sine wave was like dying for some. It was like getting compressed, and that's due to we're not treating the MOSCAP. And I had to talk to my industry buddy about this, and he was like, "Oh, MOSCAPs are only great for what do you call it? Decoupling or not decoupling? Yeah, decoupling. So like storage tanks. You put them at the edge of your like your circuits, like, or the beginning of your circuits, and they like hold like a steady charge. It puts the impedance pretty good. All right, so that was something I completely forgot. So these MIM caps, and I wanted to do something cool with them. They're metals. They're not active. They're just pieces of metal. They have a little insulation between them, but they're good for signals. And I've never worked with a process this small. So, what's his name? I had to make a lot of verification calls, and yeah, this is the right way to do it. Anyways, this is a high pass filter. In, out, boom. Okay, so I'm gonna exit out of that. I'm gonna go to my schematic or layout or symbol. Okay, what am I gonna call this? HB. Okay, and then in, out, VS. Boom, easy. What about my layout? Okay, yeah, this is gonna be the funny puppy, huh? How do I get this to show? Because I'm gonna get a question. Someone's gonna do the assignment and be like, I can't see anything. If you already did the hard part, okay? If you did all the hard parts, it shouldn't be too bad. There we go. I'm gonna go to File, Browse. I'm gonna browse to my display options. That's what I chose. Load from. Boom. Okay. Is that cute? So I kept the same resistor. So I'm gonna move this puppy up here. Bang. Okay. So then I'm gonna nuke this guy. Should I nuke it? Yeah, I'm gonna nuke it. There you go. Boom. Okay. I'm gonna instantiate. What do you mean instant? Oh, don't you love Cadence? MIM cap. There we go. And hey, it saved my defaults. Great. Come on, Cadence, work with me. Okay, come on, mister. I don't like this, but we'll see. Come on. Please don't crash on me. Save. When you feel like it's gonna crash, just save. There you go. Come on. Come on. Rotate to the right. There you go. Or do we want to rotate it? I don't think I want to. Come on. Who's burning the Cadence servers right now? Or is it my Wi-Fi? I'm using the Wi-Fi right now. Oh my goodness. Come on. Okay. I'm gonna do something funny because I'm as a layout engineer, you wanna kind of keep yourself like give yourself some space. So there we go. Okay. So there's my R. Here's my C. I like this. Okay. And you know what? Here is the, I'm going to put it right here. Give us some time to travel. Yeah, right there, whatever. Okay. So this was a pin that I created. You see this right here? I'm gonna move it. Watch this. Oh, come on. That's my metal 1 pin, right? Do you know why I'm saying to put pins on metal 1? They're pretty easy to find. Don't believe me? Press metal 1, press no view, and then boom. You see all the, let me get rid of that. See all the blue? Come on. See? Oh, you see that random, what's that pin? That's got to be your V out, right? And this right here is, what do you call it? VSS, right? Or was it S sub? I don't remember. I think it's VSS. And then that's your input. What's that one? That's the, what do you call it? The other end of the resistor. So anyways, because I want to get this done fast. MIMCAPs are on level 10 and level 11. Let me see. Let me just verify it. Level 10. This is via 10. This is level 11, and this is the cap metal. Okay? So this pink area is what makes the capacitor. So we need to obey the laws. So I'm gonna put metal 1. Okay? This might help you too. Okay? I have metal 1, metal 10, and metal 11, and these other guys on. Let me put a. Do I need a contact? Nah. Just put that right there. Via 1. So what I'm gonna do is I'm gonna press O, and I'm gonna create a stack from metal 1 to metal 10. Because the top of the capacitor, the top of the capacitor's got to be metal 11. There we go. And let me make it a 5 by 5 question mark. Yeah, let's do that. Yeah, sure. I want to give it some space because I don't know the DRCs. We'll find that out the hard way. Yeah, let's put it there. Okay. Now I'm gonna go from metal 10, and this might help you too. You see, I like doing this right here. Right there, boom. I'm gonna stretch it like this. Oh, sorry. Like that, and then I press escape, and then press S. Then I do this, and wait a second. This is metal 10 or metal 11? Wrong metal. If you're using the wrong metal, let me see. You can do the following. Cue this, press this, and go here, apply, boom. Now it's metaled. There we go. And then I can move this right here. There you go. And then, is this gonna annoy you? Yes, it will. Boom. And then, this, boom. Told you this is gonna be an art class. There you go. Boom, boom, boom. That's the top. That's metal. That's metal 10 or 11. That's what I'm hoping it is. If it's not, I can just easily fix that in post. Anyways, so now what I'm going to do is I'm going to create a via metal 1 to metal 10, okay? And just put back metal 1. And this needs to go... I'll just put this right here. Okay. And now this one can be connected like this. Okay, like that. Oh, come on. Come on. There you go. There you go. And you see how easy that is? And then, because I have OCPD, I'm going to press M to move. You see now, once you start memorizing all these hotkeys, there's a way you can change key binds. I'm just going to talk about that quickly. Options, bind keys, not key binds. And you can change it for anything, your layout editor, your schematic, symbols, you name it. And you can save it to a file too, okay? So if you have like a gaming mouse, like with the numbers, like you play, I don't know, play League or whatever, you can map it to button 1, 2, or 3 or whatever, okay? Button 12. But anyways, layout becomes super fun and pretty exciting, especially for tape outs. Anyways, here we go. I'm gonna complete this. Let me just put all views. This is plus. This is okay. Let me just do something funny. I'm gonna flip this, rotate, flip horizontal. There you go. Okay, because my minus, this label right here needs to go over here now. Okay. Okay, boom, boom. And then I'm gonna do metal 1, no view. I'm gonna do this because I'm trying to get out of here. Boom, okay, all view. And now I just need to connect this minus terminal to VSS. You see how I planned this all? Boom, boom, and just right there. We'll fix the DRCs later. Save. Is that looking good? Get rid of this. Is that my high pass filter? Anyways. All right, you know, let's get with it, okay? I don't even know if this is gonna work. I really hope it does. If it does, I'll cry. I'll go home. Run data. If you do it like this, if you create a folder, my DRC runs, okay? Choose, okay? Dump it all there. Rules, technology, GPDK. Let it do its thing. And then submit. Yeah. It's working, it's working, it's working. Okay, let's see. Soft check. My high pass filter. P substrate missing stamped connections from P tap. But where? Other than the whole thing. So you know what? Single P sub. Let's give it to it. Let's give it the P sub stamp. Whatever. Just put it right. Yeah, right here. Okay. And then okay. This is what I was talking about with the reruns. If you just press this button right here, it'll rerun it for you. So it's blank, okay? What do you mean? Oh. Metal must be really big, and oxide also must be big. Okay. Greater than 35 nanometers and greater than 20 nanometers. Okay, great. Okay. We're getting there, y'all. Make it a 3x3. Okay. Save. You can either go here or you can go here. You can press rerun anywhere, okay? Rerun. I'm showing you this so that when you're doing your projects, you can just boom, boom, boom. All right? DRC is probably your worst friend, best friend, worst enemy. You'll see. You'll be like, get it running. And we're good. Woo! Okay, DRC's great. Now let's go for your, what do you call it? Your bestie, the LVS. And the LVS, yeah, makes you cry. Okay. If you make a unique folder, my DRC runs, my LVS runs, I'm going to show you what's going to go. Hopefully I don't have to, but if you have to, I'll show you what's going on. Let me see there. Okay, set your rules. Don't forget to go to input, change your pins to geometry plus text, submit. And then basically this right here is saying, hey, remember that thing we did last night? So, like, we still remember it. Do you want us to overwrite it? Yes, because I don't want you seeing what I did. Or lots of LVS errors. Anyways, I'm just praying it works. Oh, gosh. This is the heart-pounding moment is where it's like, just work. Cadence can be your best friend. You'll spend nights. It's like when you spend those nights doing EE360 MATLAB and you're like, why is it not working? Oh, something really silly. Let's see. Okay. Oh, it didn't pop up for me, but right here you'll see it. My DRC runs. Here's my LVS runs. Okay. Let's open it. All right, let's see the crying. Mismatch labels. MIMCAP? Okay. Unattached labels. What do you mean? Let me check. My high pass filter. This is in, this is out. This is plus. CO plus. CO minus. That's the thing I'm not getting. Because I don't want to waste too much time on this. Let me see. Cue it. Attribute, property, parameter. No, I don't want to do that. Is there a setting here that will let me know if I'm labeling everything right? You know what? Let me check something. I'm gonna go to options, display. Let's label the nets. Let's label the dot pins. Let's label what other instance pins. What other labels do we need? Yeah, I think that should be it. Let's see if it works. Apply. Okay. Oh, that didn't work. In. Out. Let's see the other LVS error. Comparison. VSS. Shorts and opens. So on my layout and my schematic, it's open, but my layout it's there. What? I'm trying to figure out what's going on here because this is getting very annoying. It doesn't like this capacitor. It doesn't like this. And it's saying something between here and here. It makes no sense. Yeah. You know what? I don't want to waste too much time on that either. Let me see. Mismatch. I really hope that's not the error. Let me try one more thing before I give up. Boom, 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 boom. Okay. Let me just click on this. Hello. Oh no, it's crashed again. Exit. Reopen it. Uh-oh. Come on. There we go. I'm going to look into this cell. Plus, minus B. Control E, Shift, Control E, Shift E. Oh my goodness. It doesn't like this term. It really doesn't. Let me cue it again. Where is this going? Yeah. I really want to get this signal capacitor to work, but let me try this. If it doesn't work, I'm going to sleep. Okay, I'm going to erase that. I'm going to call this a pin. I'm going to call this pin the MIMCAP, MIMPIN. There we go. And this one, MIMPIN P, is an input output because I don't know what it is. RR. Go. Save. Don't check. Or unless you want to see the error. Okay. Go here. Symbol. This is an emergency layout, okay? I'm going to do something funny. Copy. Boom. Paste. Boom. Maybe you engineers can figure this out on your free time, and then you can tell me the answers, and then I have 20 other brains to tell me what I'm doing wrong. Mim pin. There you go. Because this is what I was spending the whole weekend. I'm getting PTSD already. You'll see what I mean. Check and save. Boom. Okay. Okay. Which means, oh no, it's gonna. Oh no, I know it's gonna happen. Oh no. I think I don't want to run this anymore. Let me see. Layout. Because the next thing is gonna bark is, where is the third terminal here? And I'll tell you this, it's not there. It's a 2-terminal pin or device, but it's asking for a third terminal, so I'm just gonna give it what it wants. You know what? Don't do what I do, but you can follow if you want. I'm just gonna create a box. Control P, mim, pin. There we go. On metal 1, there we go. Oh, U, Control P. Keep first name, create label, boom. There we go. See if this works. If it doesn't, I'm just gonna go home. Anyways, watch this. This is what I'm talking about. This is what I was doing all weekend. You see how we have the results viewer? I'm gonna click on this right here. My DRC runs, right? I'm gonna press this button. See? You don't have to do that like reiteration again. You just run it and it lets it do its thing. It popped up. Okay, it DRC'd. Great. But now I need the LVS. See? You just click on the LVS tab, then hit that play button. Your life, like, boom, it becomes a lot easier. It feels good, but you at least want to have it LVS. So use this as a training, what do you call it? Training thing. I'm getting errors there, and I'm getting mismatches. Unattached label, MIMCAP. It doesn't like that MIMCAP. Yeah, something's wrong. You know what? I think I know what it is. Remember that thing I was talking to you guys about the metals? It's metal 11. Metal 10. Would it bother anybody if I did the following? Let me see. I'm gonna copy paste this puppy because I like this guy. Okay. Delete this. Okay. Because right now I'm just trying to do something cool. Okay, that's metal 1. Okay, put that right there. Okay, so I'm gonna do this. Go to metal 10. I want to replace this and change this to metal 11. Hear me out, okay? Metal 11. Okay it. Boom, boom. So now that's connected to metal 11. Okay. Now it shouldn't cry. Move this here. Boom. What am I going to do here? Change this to metal 10. Okay. Boom. Boom. And then stretch. Boom. Is that better? Save. Let's see if this was the error. First, I actually don't know if the DRC is going to work. Let's just run it. Run it for fun. Yeah, like this process of like Pegasus, just clicking on the my DRC runs, my LVS runs, pressing the play buttons, it becomes so much more like fun to just start investigating things that are going on. See, the DRC ran. Go to LVS runs, click on it, let it run. The folder disappears, and then it comes back. So if this doesn't fix it, I'm just going to go right into the low pass filter because I don't want to talk about this anymore. I'll research that on my free time. I'm just showing you guys the pain that I had over the weekend. Okay, still the same problem. Unattached port label. Label minus unlabeled at 1.5, 1.5. 1.5 on what? Port label. Unattached label. Okay, now I'm getting a lot of errors here. Mismatch nets. Missing connection. Error. So I think the way we had it right. Too bad I can't U this. Yeah, I can U it. Anyways, I'll fix this on my free time. But you see how I was trying to do this rail over here? That's what I was thinking that was gonna be or something. But anyways, get rid of that. Close out of this. Close out of this. And then let's go to your low pass filter. I'm gonna go to my tutorials. Yeah, I tried doing something here. Here's your low pass filter, right? That's what you guys are going to be doing for your assignment, correct? You can see that, pretty cute. What's his name? Here's my AC response, and let me show you what I was looking at. Aha, I know what that is. Check and save. Launch, ADEL. Session, load state. See, I don't have to do that painful simulations again. Sim AC. Boom. Sounds good? Now, let me show you what happens if you don't put a volt in here. If you don't put DC, like 1 volt DC. So, let me show you. If I do the following, because I thought this was going to work, but it didn't. I'm going to put 0 volts for my DC. Okay it. Check and save, because we changed something there. And then I'm going to, because I'm going to lose all this work, but it's fine. Play it. Anyone see something funny? Voltage. Home. What? Let me see something. I remember during the weekend, if you don't give it, let me see, if you put like 0.5, I'm going to put 0.5 DC, okay? Because I was seeing something weird on my end. Unless something magically happened. Yeah, okay, it's okay, interesting. AC response 707. See, where's 707? Right there. M. Okay. That's interesting. Okay, it's not doing what I wanted to do anymore, but that's okay. But let me see. Can I move this to a new window? Send to, move to new window. Okay. Is everyone understanding this plot? Let me see. Move that plot right there. Boom. Right, phase. How do we find the what do you call it, the knee frequency on a phase response? How do we find it? I'm actually getting pretty sad right now. How do we find it for a low pass filter? What's the frequency supposed to be at 3 dB or at the knee frequency, right? We have the 3 dB, right? What's the phase supposed to be? 45 degrees? Is that ringing a bell to anybody? No? Really? Yeah, the Bodie plots. You guys didn't learn Bodie plots? Oh my goodness. Okay, that's. Uh, I'm very surprised. Okay, I'm not liking that. Because I'm trying to force my students in the lab to learn it, and they're like, 221 they don't know it, which is fine. 320 they don't know it, and I'm like, okay, I'll make sure you know it. So now my 420, because I think a majority of you, I don't think we've touched four. Funny enough, I don't think for your class we were able to touch it because I chucked it out for a PCB thing, which I thought was more valuable. But for cadence stuff, this is where you need to learn your Bodie plots. Okay, at 40, you see right here, 45, right here, we're getting about, let me see, this right here is close, 11 gigahertz, right? 11.5 gigahertz. And then what about my my decibels? Where's my decibel plot? Where is it? Oh, right here. Cool. Can I just want to, let me send this one to a move to new window. Boom. Where's my 3dB? 3dB is right here. Emmet. There you go. 3.07. Close enough. 12.3 gigahertz. Close enough, right? Is that making sense? That's our 3dB frequency when our bottom term 1 divided by 0.707. Or no, it's 0.7 or 1 over square root of 2. Yeah, that's it. 707 or 707 millivolts. All right. You see that frequency, 12 hertz, gigahertz, correct? I'm going to go to my, let me see, go to my transient, okay? I'm going to open that schematic, okay? Check and save. And then launch ADEL. Session, load state, because I already did all the hard work. You guys have to follow that. The manual, or what do you call it? What I gave you guys. There you go. Simulate transient. Boom. Nice. Okay. Where is this guy? It's whatever. Let's rerun it. So let me, or not rerun it. Let me go here. Cue it. I'm just gonna put 12 gigahertz. Okay. Check and save, run it. Does that make sense right there? Full AC amplitude, right? Let me just zoom into it. What's the phase difference? Measure, measure. Click here. Click here. 65 minus 52. That's about 13 picoseconds, right? So we have 13 picoseconds. And then we have, what's his name? We're trying to look for the phase. You got to convert seconds into degrees. So that means, multiply your time, right? Multiply time by frequency, right? So because that's seconds times 1 over seconds. Is that correct? Because now you're going to get the cycles, but every cycle, right, is equal to 360 degrees, right, divided by 2 pi. Is that correct? See, this is where MATLAB comes to play. MATLAB. Guys, imagine running MATLAB in this class? No. You can technically export this into MATLAB, and you can do some more digital signal processing. So if you needed, like, if you're doing some funny filter for your like DSP projects or some implementation for your thesis, you can export cadence signals to MATLAB, do more digital signal processing to prove a thesis point. Okay, let me see. What do you call it? Here, what's my delay? Delay was equal to what did I say? 13 e to the minus picoseconds is 10 to the minus 12, right? And then I'm gonna get my phase is equal to the delay, right, times my frequency. What's my frequency? 12 gigs. 12E9, right? Right? Is that correct? Come on, engineers. We got this. Freak times 360 degrees, right? But every 360 degrees, we're going to have that 2 times pi. Does that make sense? What are we going to get? Something's not right. Nano is -3. It's E -9. Did I do something wrong? Let me see. Picoseconds. 865. Because this looks like 45 degrees to me, right? Something's wrong. 54. Did I do the calculation right? Let's go to MATLAB. Because femto is -15, pico is -12. This is gigs. We have our time, right? Picoseconds, right? Times our frequency. So this is going to give us a small number, 360. That's our degrees divided by 2 pi. Right? Yeah. To calculate phase shift. Yeah. Let me see. It's going to be, what was it again? What? 2 pi times frequency, man. Formula for phase shift. Because I'm trying to calculate the phase in degrees, sine waves. Yeah, 360 times that over that. Oh, did I multiply by when I shouldn't have? Maybe I have to get rid of this. That's close enough. Is that good with everybody? Actually, I think it was supposed to be 10. That's much better. Okay, I added an extra 2 pi term. You see, I'm sleep deprived, anyways. 43 degrees. Is that good? Is that matching what this is looking like? Right? I'm gonna do something cool. I'm gonna go here and let me show you, because I told you let me see. Sine DC level, okay? If you put this as 0, okay? Watch this. Apply, okay it, and let's watch it break. Watch it break. Boom! It broke. This is great. You see, our V in and our V out are kind of the same. It's like think of like the V in is like doing this like a jump rope, and V out is like doing nothing, so it's just kind of following it too. See, this is not right. Anyways. And then let me show you what happens when you do the following. 0.5, okay, apply, okay, check and save. Come on, check and save. Where is my sim? You see that right there? Okay, we're getting it there. Okay, you see how this? I'm gonna take a screenshot, okay? Because I'm seeing some. There you go. Memorize this picture, okay? I'll pull it up. Cue it. 1 volt, okay? Check and save. Watch it change. Not too much. Is this the same as this? Close enough, right? Actually, looking pretty good. Yeah, it looks okay. Interesting, okay. Anyways, what happens if I throw a lot of voltage into it? Like this. If I go here, and if I did the following, let me do a, I'm gonna break it. 1 volt. Okay. Check and save. Boom. Let me see if I can squish this thing. Do you see that? I think it changed a little bit. Is it getting squished? Do you see how this is curvier and this is like kind of like right? What if I lowered this? Let's break it one more time, and then we'll wrap up here, okay? 2 volts, okay? And this is why I tell you the simulator is your best friend. It'll tell you what's going on. There you go. I broke it. And why is that happening? It's because we have a MOSCAP, right? It's an active device, and it only works at higher voltages. So you got to make sure. Let me go back to the layout. So many libraries. There you go. This is what you guys are going to turn in for your assignment, right? Right? Easy. How do I turn this device on? See the gate right here? Has to be pulled up high, right? How about the source, the drain, and the body, right? Have to all be tied down to ground, right? Or VSS, right? So it turns on when this difference is really high. But then the minute this output or this goes down to like, I don't know, like 1 volt or not 1 volt, half a volt or 0 volts, you get, where is my sim? There it is. You get this. You see, it looks really nice up here, right? But then as soon as it goes down here, it's like, actually here. Yeah, close around like 300 or 400. Yeah, you see right there, 436 right there. And let me just click on 369 or 414. So anything below this is not going to work good. So if you wanted to use the MIM cap as a signal capacitor, you can. You just need to operate between, I'm going to throw a ballpark number, 1 volt and 4.36 or 0.4. So yeah, you see this area right here? You can use it as a signal capacitor, okay? But then you're going to just be playing with like DC biasing, and it's going to be a hectic nightmare. So that's why I was trying to see if you can use the MOSCAP, or not MOSCAP, MIM caps, metal on metal capacitors, because those are independent from the voltage. Well, there's fringe capacitance too. But else, this device will work, okay? Are there any questions about the assignment? Everyone's going to be good. And then I think I wanted to talk about current meters and everything, because what else did Dr. Mingzu talk about in his class?
Still current mirrors, but then we got into
amplifiers.
We just touched on differential amplifiers.
Diff amps.
With the capacitor, filtering.
Yeah. Let's break into his class. You guys don't think I see your class? Not really. Let's see.
I mean, it's cool stuff, but I understand zero.
Which one? This one?
You're not alone.
Let's see. Electronic. You guys like this? He uses the same cool IC chip background. Oh, this is cute. How you guys are learning? Yeah. This is this is not the Razavi book. BJT current mirrors. Current mirrors. Yeah, these are cute. Oh, you guys are okay. Okay, cool. Cascodes. Oh, you guys are learning really fast. Yeah, this is fast. Like usually Dr. Baker would spend like 3 weeks on this. Because he's religiously, diff pairs are probably one of the most fundamental things in the world. Like this right here is its own study. Like it's an interview question. Every interview, like at any IC company, you need to know this by heart. What's the body effect? The rise time, the impedance of the actual gate itself, the mismatch currents, The percentages. Oh, stuff like that. Yeah, I see stuff like this. Yeah, okay. This is not that bad. He's doing a good job. Yeah, or not. I don't know. So you tell me.
This was covered in a week.
In a week, dude.
Okay. In a week, yeah. You know what? I can see why. This is a poll. Yeah. Current.
Each slide is like 26 slides in 1 week.
That's a
He
lot.
has class for like 30 minutes and then he ends class in 40 minutes.
Yeah, we spent like 2 days on this right here, common mode rejection ratio. It's very important because you want to make sure your nodes, if there's a little bit of difference, you want to make sure it rejects it. Or common mode, like the DC component. Okay? Yeah, this is a lot. We derived this in Baker's class. DC offset, yeah.
So me and a group of other students talked to him after class and he was asking us about the pace. I told him that I think it's a little fast.
I think it's too fast because honestly,
Yeah.
if I were at your time, probably by the month of I think March or April, like early April is when we would start talking about this, and then you would only get I think 5 weeks to do your final project.
Do you know what class Dr. Baker covered this information in? Was it also
420.
420?
Yeah, 420 because we don't talk about BJTs.
Okay.
We just talk about NMOSs because that's the future. Okay? NMOSs and PMOSs. Honestly, I think maybe you guys might be a little late because I think this should have been. I think personally, if I were you, I think I would have talked about this puppy. Let me see. How do I zoom in? Zoom in. I would have talked about. Let me see. This guy right here. I would have talked about that like the third week of class.
Before these slides, everything was pretty much review of 320.
Yeah, because I don't blame him. That was Dr. Baker's biggest complaint is that his 320 students didn't even know what a MOSFET was.
Yeah.
They didn't even know what a BJT was.
Yeah, but
So you know what? I don't think it's Dr. Zhu's fault.
we had Zosh.
I'm not saying it's Dr. Zai's fault. I'm saying maybe there's something fundamental. And that's why I want to teach the 220, 221, 320, 420. And that's the reason why Dr. Baker stopped teaching 400 because he was getting all these students who didn't know what to do. So he went to the elementary and then he did this thing where he went with everyone. By the time we went to his 400 level classes, you guys were talking about how to build differential amplifiers by the first week.
Yeah.
Oh, amazing. Anyways,
Oh, yeah, it's because of 220 and 221 with Dr. Baker that I somehow survived 320.
it's all good. But anyways, easy layout. Not too bad. Everyone's going to have some cute homework assignments for tomorrow. You can honestly choose this in 30 minutes. You see how fast that was? All right? Have a good day.